Hi, I'm Kylo. I am a JavaScript developer. I currently work as a React developer. But yeah, JavaScript is like it's been a journey trying to get to grips with JavaScript. I've been a developer for a number of years, but I think like many other developers, you learn enough to build some cool stuff. I struggled with JavaScript a lot, and especially in the early days, after having come from HTML and CSS, I found JavaScript to be a really big jump. That sort of transition took a while, but then once I was able to write some JavaScript and be fairly comfortable with it and move into React, I did find that I was able to start building stuff. And that's brilliant and exactly what you should be doing as a beginner. And while you're learning, you want to be building as much as you can. And even when you're past the beginning stages, no matter what stage you are in your career, you want to be building. But I definitely reached a point where I realized my knowledge of JavaScript was lacking. I found that there were some concepts that I had to keep looking up, no matter how many times I researched how does this variable work again? Like, where does it point? Like, I've forgotten again, and I've got to go and Google it, which is fine. That's, as developers, we Google. But when it comes to the fundamental concepts, there were just some things that I weren't quite grasping. And if you have a similar experience, I'd actually love to hear. Please just leave it in the chat, and maybe we can come back to it at the end. Or yeah, just to share with others. Like if you have experienced similar frustrations with JavaScript, especially while learning it, and maybe being able to write a React application, which is fantastic because a lot of that complexity is abstracted away. But even React is based on all of these like fundamental concepts like closures, which you don't necessarily have to always interact with or grasp to begin with, but you do reach a point where you have to understand it to grow as a developer. That's where I got to in my career, and I needed a way to visually break down some of these concepts. So I created something called the Great Sync, and here's my website, Twitter, Instagram, if you just want to find out a bit more about it. It's really just a way of, for me, it started as a way of just understanding JavaScript and building a picture of JavaScript, trying to see how everything like fits in. That's what was the idea. That's what I wanted for myself, so I could take into interviews and not have to panic because I can't remember a concept. I've got visuals that are always a lot easier to remember than a definition that I've read in the MDN docs. And from that, it's sort of built up, and now I use it regularly to coach, and I'll use it at Codebar. So I'm a coach at Codebar if someone does want a JavaScript problem explained, and I'll do a lot of coaching on the side and at my job. I'm using this because it does help, whether you use a analogy visual image like what I'm going to show you now, or whether it's just drawing, doodling on a whiteboard or a piece of paper with someone you're coding with. Always breaking it down into something visual that our brains can better comprehend helps, with the code that you're writing and with your communication, and then of course with your understanding of the problem. So yes, JavaScript is hard. And as I say, I would love to hear any stories that you have or feelings you have around JavaScript, any frustrations, even if you are quite far in your career. Like for me as a React developer, even now, like I still come across things where I'm like, oh, there are some things here that I really need to focus on. And, it gets me down sometimes that I don't have a full grasp, and the whole imposter syndrome starts again. You're like, oh, I'm not a real developer, or I'm not like everyone else who just seems to build amazing stuff and understands everything. I think those feelings, are all part of being a developer. So yeah, like I say, I built a model. I call it a model because in reality, we all have mental models. Any way, any means of understanding something, we have to apply a mental model. We build this model over many years through trial and error, where we have a theory for how something works, maybe a basic understanding, and either that understanding is validated through trial and error, or we come across a problem that just exposes our lack of understanding of that concept. And this can take many, many years, and it should take many years to build a really firm mental model understanding of the language. I call mine a visual mental model because it takes the same approach where we're building a framework for understanding JavaScript with layers of understanding. So everything in my images really do communicate an idea concept of JavaScript. And if I have to try and work something out, I'm able to relate it to this model, to work it out using this model to try and make sense of it. The problem I want to talk about today is reference types that we find, in terms of the different types of JavaScript values that are in the JavaScript engine. What are reference types? And reference types become really important when we clone an object. So I'm just going to write a bit of code and show you the line of code that I want to understand with you and break down visually. So I'm going to create an array, and I'm just going to call this our original. So this is our array. And inside, I'm going to put a #1 number value and an object. All right. Inside of this object, I will just put name. Now, I know this is something that you won't often come across in production. I mean, you might, but it's rare that you will have so many mixed values inside of an array. But now and again, you might. Either way, that isn't the point of this. This isn't to show you like, oh, this is what you would encounter in a real work setting. I just want to understand what is going on here. The fact that we have two different values inside of an array, and now I'm going to create a new array called, I'll just call it copy. And you may or may not have seen the syntax before, but if I wanted to copy or clone this array, we use something called spread syntax, 3 little dots, and we write the name of the object or the array that we want to copy. So at this stage, my thinking is that I have an exact copy of what's inside of this array. So if I go copy, so I'm referencing this array, and I want to grab, because I know this is what's inside of this copy variable, I want to grab the second value inside. So we use square bracket notation, and we put in a number for the index of that value inside of the array. And now I want to access name, so we can use .name over here, and I'm going to set it to something else, like Charles. The question is, oh, I actually wrote it down here for myself. What is in the original? So over here, I've changed the copy and the object inside of it to Charles. What would we see inside of the original array now? What name would be inside here? To answer that question, and I know you might know the answer, and it does have to do, well, it has everything to do with reference types in JavaScript, but whether you do or you don't understand, what I want to do in this session is just to work out why. What is going on inside of this spread syntax where we are copying this array? What is happening and why is it happening that way? And when I change a value inside of it, what is going on there? Why am I changing? Am I changing the original or am I changing the copy? So to begin with, and I do hope you guys just stick with me sometimes for the random imagery I might show you. I purposely try and make the visual something memorable, something that you don't often come across, just because it's easier to remember. Plain standard imagery is great, and I think our JavaScript sort of blogs that you might read and tutorials do make good use of analogies, but sometimes those analogies are just too plain and standard to remember. I don't know how many car analogies you may have heard in your lifetime as a developer, especially when learning classes and object orientation, but there's many, many car analogies. So there might be some things here that seem a bit weird, and if you could just stick with me and imagine it. So our environment, our code, we're going to imagine as water in a defined environment. So we have a defined environment and we have scope. So this sort of lighthouse here represents the scope. And I'm not going to go into scope in this session, but that comes with every environment where we write our code. And just like water that flows in following a gradient, following gravity, top to bottom, our code will flow from the top and work its way down to the bottom until it eventually overflows and returns something. In this environment, we find a few things. We find things like statements, we find things like loops, but we work with values, and values are the thing that I want to focus on here. Values are broken down into primitive values and reference values. So primitive values, like what are those? Well, you may have heard that term before, and you might be able to say them off the bat, like this was an interview. Can you name all the primitive values? But if we were to name a few, we know number is a primitive value, a string is a primitive value. We have true and false Boolean is a primitive value. And yeah, feel free to list the others in the comments, because I don't trust myself to list them all now in the session. But primitive values for our mental model and the way that we're going to imagine what primitive values are islands, natural islands that are found in the natural world. And there's a few reasons why we're going to picture them as islands. Just like an island has coordinates, like a set location, values in our JavaScript engine have a set location. They have really just a same as a list of coordinates, a string of numbers to say this is where this value exists inside of the JavaScript engine. So that if we wanted to use the number 1 or a string or true or false inside of our program, the JavaScript engine knows where to find these. Primitive values are singular. We only ever have one. Just like in nature, you don't have two of exactly the same thing. Yes, you might have twins, you might have, things that look the same, but you'll never get exact replicas. And that's the same with primitive values. There is only one IAM string in the entire JavaScript engine. There is only one memory location for that string. Islands are also physical, and it's good to think of our values as something physical. Now, I know, again, there's something weird in the front here. We've got a loo, a random toilet in the front, and that is linked up with how I explain assignments with the first three letters. They're sort of giving it away. But yeah, for the moment, don't worry about the random loo in the front. We're focusing on the fact that we have a physical location for each value. And all of these primitive values will be different islands, different types of islands that we find in our environment. But then what are objects? And objects, I mean like objects, arrays, and functions. You may have heard that everything in JavaScript is an object. That's not true, because primitives are not objects. But yes, objects, arrays, and functions are really all just types of object. These are very different to what you might find in the natural world where we write our code. So instead of having a natural island, we now have something that's constructed. We have something that's built. We build objects. We don't find them in nature. We don't find them in our JavaScript engine. We build them. They are represented here as different ships. So we've got an object ship here. We've got a submarine, which is meant to represent an array because it's got a linear list of values as opposed to a sort of a scattered list that we find here. And functions are just very similar. So functions is also just another type of ship. You might notice we have these weird genies inside of the ships. When we put values inside of objects, we don't store values. So if we look at our original example, our original code over here, so the number one we know is a primitive value inside of an array. Our number one is represented by an island, a physical island. In our mental model, it would make no sense to put an entire island inside of a submarine, of a ship. You just can't. It's just not physically possible. You can't fit an island in a submarine. What you can do is use a pointer inside of that array to find that island using the coordinates, because an island has coordinates. Values have a set location. And that's what objects and arrays are. We have a set collection of pointers that point down at the values in the natural world. So all of these will have names. These guys won't have names. They'll have numbers starting in a linear progression because it's an array. But when the captain points at one of their pointers and asks, point at, find the number one for me, then we have our genie who is always able to provide the value you're looking for, will shine down onto that island. And that's just a way for us to understand objects. If we're not putting things inside of this craft, we're putting pointers inside of them. Another thing about objects and arrays, and it's very important, is that they aren't part of the natural world. Like I said, islands are. We can find them. It's something physical. They're islands we can visit. Objects and array ships live in something called the heap. So it's actually in our JavaScript code, they actually live in a completely different environment. Somewhere that is invisible, actually. Like we can't find objects and arrays in our code. They are invisible. I call it the heap multiverse. Like multiverse as in, you can have multiple versions of things, because unlike these primitive values where I said you can only find one of them, in nature there aren't two of exactly the same thing. That's not the same in terms of objects. Objects, you can have 2, 3, 4, 5, 6 different objects. But they live in this heap multiverse that is like a parallel universe to the natural world where our primitives lives. And this is going to be important in a second. You'll sort of see why that is relevant. So if we were to look at our code, this array, const original, and there's our array with an object and our primitive value, it would look something like this. We would have our island and we would have our ship. Although technically, like I said, an array is an object ship itself, and we don't put things inside of arrays, we point at them. So there's our first property, pointing down, shining down on the number one, and there's our second property, shining down on the ship. The problem with this understanding so far is that objects are invisible. So we wouldn't actually be able to locate this object. That isn't possible using this mental model we have of ships and arrays that live in the heap multiverse. We would be able to find a physical island, but not an flying object. So there's a problem with our mental model here. And this is where we get introduced to reference islands. So the JavaScript engine gives us something special. It says, okay, you as the coder need to be able to access objects and arrays. I mean, we wouldn't be able to write very good code if we couldn't use objects and arrays, but they're invisible. We can't use them in our code. So instead, what we get are references. So we get an island, a physical island with a set location, just like our primitive islands. They're not very special. Like you may have seen the different types with volcanoes and sand and all the other types of primitive values. No, reference islands really are it's just a slab of rock. But the one thing a reference island has is a means of locating that object that exists in the multiverse, in the heap multiverse. So it's always equipped with a special telescope that can see through and locate. The important thing is that we get an island to work with in our code, and we call them reference values. You'll hear this term all the time, pass by reference. You know, when you provide an object in a function as a parameter, you know, something like that, you're passing the reference to it. You're not passing the actual object. So again, if I were to come back to our code, that array, we have our number 1, but we don't have a ship now. We have a reference to the ship. We have a way of finding that ship. So what actually happens when we clone the object? You know, we talked about using the spread syntax. Now that we have this better understanding of what this array is, that we have a primitive value and we have a reference to this object. We don't have the object itself, we have a reference. Let's now go to our second line here and break this down and try to understand what's happening here. I like to think of it like this. As soon as we want to copy 2 arrays or 2 objects, we need to line up the 2 vessels, the 2 ships. So let's say this is our original and this is our copy. So we line them up. And we know in each of these, so this might look like a weird visual. We're looking top down. So we're above the submarines and we're looking at, you know, from the top. We know that inside of them are those window genies. Let's just go back to that picture again quickly. So inside of the array, we have our properties, or our values, our value pointers who are able to locate those values. And we picture them as genies. Genies is our way of finding values inside of our JavaScript engine. A genie you ask a question to, like, where can I find this value? A genie is able to answer that question. So when we have our 2 submarines lined up next to each other, the first thing that happens is a bridge gets spread out. And notice the word spread. We spread the bridges out from the hatches, from the windows of each submarine, of each array ship. So often the terminology can be tied into the visuals that we create as just a means of helping to remember syntax. I don't know about you guys, but I often forget the terminology. And it will come out in interviews sometimes when, you know, they ask about some term that you need to explain and you don't know what the term is. And you might ask them, oh, sorry, I don't actually quite understand that. Can you tell me what it is? And then as soon as they start telling you, you're like, oh, wait, I know that. I know exactly what that is. The terminology and the vocab is actually an important part of being a developer. It is good to practice using the right terms, using the right vocab, because as soon as you come to communicating those ideas, it helps just using the right language. So where we can with our images, with our mental model, we even using story or whatever, you know, different names for things like the heap multiverse, if you want to remember the data structure that keeps objects and arrays, tying in the vocab helps. So bridges spread out between the original array and the new one that you're copying to. And on this bridge, on each bridge, the genies from either array come and meet in the middle, and they look at a globe. And all they're doing here is showing the new genie from the new array, the one that is the copy, where each value is. So that might be the number 1. That's where the number 1 exists. It's the reference, the coordinates for that number 1. And then the further along on another bridge, there will be a similar exchange where they will show you where the reference value is for an object. Not to the ship, not to the object ship itself, which is invisible and is just inaccessible, but to the reference that has that telescope that can find it and knows where it is. The genies are able to pass that information to each other. That they can work with. So if we were to look at it from the top, we would have our genies spread across bridges, and they are looking at globes. And the 3 little dots, for me, I remember them as 3 globes, finding those values, pointing them out, and that's how our copy now gets genies which know where these 3 values are. So back to our code here. Let's just over here. So now that we know this is a reference, if we go and use copy 1, let's just move that there. So copy and change the name property, that value, to Charles, what do we think original 1 name would be? Charles. And why? Because when we copied here, we're not getting a completely new object ship. What we are getting is the reference. So the references are both pointing to the same ship up there. We're getting the same island that points with the telescope at this object. And as soon as we change the property inside of that object, we are changing it for both original and copy. And this might seem now, I mean, it is obvious whenever you break it down like that. You're like, oh, of course that makes sense. And for a small example like this, maybe it's a little bit easier to see. Not necessarily if you are confused by this. I was when I started, but often it's bigger arrays, it's bigger objects. So you might have const, let's say, states. If you use React or something like that, you might have a fairly big state object where you will have, let's say, users, and users will be one big, well, let's say it's an array of users, and inside of that array, you might have different objects. So let's just go here, name, Kylo, and oh, that's not like that. And we have a whole lot of those like that. It helps when I actually edit in a proper editor, not Notion. So I'm doing the horrendous thing of using my spacebar to make spaces. Please just ignore that. So we have a whole lot of users inside here. And as soon as we want to duplicate this object, we now need to think, if I wanted to create a whole new state object, so I said const new state equals, and then I create my new object, and I use our special spread syntax, our 3 globes that go out for the genies to exchange the location of all the values inside, and I put my state inside of that. Using our mental model, we now know that all we have done is create a new object with a property that's able to find the same array. So the new state dot users the array that gets is accessed by writing that command is exactly the same as the array that you find when you go state.users, because it's reference values. So you will come across patterns where you will then need to go const new state dot users, and what do we need to do here is create a copy of that. So here we will create our spread syntax and go users. And it gets even more complex because we now know that because each user is an object, that inside of this, inside of new state.users, I again just have references to the same user objects that are inside of my original. So you might find even further, like deeper cloning. And that's why they're brilliant libraries like Immutable, and Lodash has methods that you can use to more easily deep clone, to not just exchange the reference values, but to exchange the reference values that are deeper and deeper inside of those objects and arrays that are nested. If you don't understand all of that, don't worry, don't stress at all. I'm just showing you the kinds of things that you might see, and it's helpful as a developer to not just be able to do this, because personally as a React developer, I could do this without really understanding it. I was like, oh yeah, just make a copy. And then when I came into issues later on, I might find it on a thread and it was like, oh no, you need to deep clone. I was like, oh, okay, damn, I should have just deep clone. Don't know what that is, but I will do it now. And I went for quite a long time doing things like that, and breaking it down and really understanding what is going on just means that things get less scary later on. I know if I come across something that involves reference values, that I have a means of interpreting it and sort of using my mental model to break it down. And if there's something that can't explain it, if my mental model can't explain it, then there's either something that I need to address in my way of understanding reference values, either there's something in the visuals that I use to understand JavaScript that needs to be addressed, or it's something that is just something that I didn't know before and can be added to my mental model. And that's what's nice when you have a structure, like almost a learning framework to approach everything you encounter in JavaScript, to build layers of understanding and not have a scattered approach to learning, which is normal, definitely normal. We all do it. But you can only go so long with 30 different notepad or notes taken down somewhere that get lost and aren't sort of linked together and easily added on top of your current understanding. It can be a bit fragmented. If that's not your experience, I would love to hear. And if it is, I think I'm not actually sure when the session was meant to end, but I am at the end. So I might just leave it open for any discussion or any questions you might have about this mental model. If you want to find out a bit more and see some of the other approaches, some of the other problems and concepts that I do break down using the Great Sync, if you just go to the website here, you can take a look, and there is an email course there that sort of, again, take you through the process of breaking down a JavaScript problem visually. But I hope that was useful. And yeah, I will now actually look at the chat. And I'm sorry if someone has put something there and I haven't looked at it. Oh, great. Thanks, Luke. That's brilliant. Yeah, it really does help to see JavaScript that can be, I mean, yes, you have your console and you're able to log things out, and there are some really fantastic YouTube tutorials and blogs which diagram it out for you. And for me, the event queue and the stack, which you can use your developer tools, helped with seeing how JavaScript runs, literally line by line. But it's still fairly abstract if you have come from CSS, which was my background, I didn't study computer science. And, to be fair, I know a lot of computer science students who did computer science, but they also think visually. It's like, just because you didn't study computer science doesn't make you the only visual thinker. It's like, I also like visual representations of things. And it can be difficult with JavaScript because it's hard to make it visual. And that's why it's been fun working on this project, because it is entertaining. I mean, I don't know how many islands with loos you have come across, but for me, that was certainly a first. I can definitely share a link. Let me just. Oh, thank you, Nadia. That's very, very kind of you. Yeah, it is something I do realize. I was sort of telling myself while I was presenting this that you can't expect people to be inside of your head and visualize it the way you visualize it. And it is actually, like, when I think about it, it's important that you have your way of visualizing it. I don't know if you've ever seen sort of memory tricks or memory hacks, and the way memory athletes are able to memorize huge quantities of information. As developers, we never need to do that. In fact, don't ever try and memorize huge quantities of information. But the good takeaways from those memory athletes are how they take complicated information, turn it into an image, and that makes it memorable. And we can do the same thing here. But the key for them was to make it personal. And even if it is someone else's image, you still need to visualize it yourself. You need to picture it, work it through in your mind, and not just read it and look at it. That's when it becomes memorable. They say things like, with the island, you need to imagine what it's like to be on that island. I don't know if you want to go as far as that. At the end of the day, we're just trying to write JavaScript and build our program. But that does help. Great, thank you. So how transferable is this to other languages? Very, very transferable. The thing where JavaScript will divert is when we start looking at the way inheritance work and classes, and that's where JavaScript does definitely become very unique. But in terms of the way values are used, execution contexts, object structures, that is all very transferable from one language to the next. And it's actually a great way. I'm using it for me to learn, to help learn other programming languages, to help compare. Like, if I now have a more, like, a bigger picture, a bigger understanding of how JavaScript works, and it makes it easier for me to compare to the new languages that I'm learning. And you can always take what is in the Great Sync and just remold it for Ruby or whichever language you're learning. And that actual process of you working through those images and turning it into something that now works for Ruby is huge learning, because you're doing the best of both worlds. You're looking at the technical concept and you're going to have to read documentation to understand it, but you're abstracting that away into something that you can understand. And that process of abstracting it is the key to actually understanding the whole concept. That's really what we're doing anyway as programmers. We're abstracting away, turning zeros and ones into a program. But our human brain doesn't work. Yes, we've managed to write programming languages to speak to computers, but we need an interface with the programming languages. We need that to be abstracted away. And our brains work, I'm speaking very generally. I know some people perhaps aren't visual learners, and this isn't for you. But generally, we do like visual means of remembering, not just remembering something, but understanding something. And if you're able to do that as a developer, even though it might seem like this isn't helping me become a better developer, why am I drawing pictures when I should be writing functions? I've often came across that while I was working on this. Like, Kyle, you should be focusing on, being a developer, not drawing, making these illustrations. But it actually really does help, because you trying to understand the concept that's driving those images. Yeah. They tend to be rather centric. Yeah, absolutely, they do. Yes, no, it is it is bizarre. And I mean, the one basic thing for me that really was transforming, and I talked about this, was the fact that objects and arrays don't put values inside of them. We say things like they're a collection, and again, that makes, you think of a collection as something like a bag that you've got a whole collection of stuff in. And that implies your model there, without even realizing it, is that objects hold all these values. And only when I was able to use this analogy of really pointers, of using a ship with pointers, that spotlights that shine down onto physical locations, then it was much easier to remember that there's no way that a ship would hold physical islands inside of its storage. It's just not possible. And it's much easier for me to remember that it's a collection of pointers to values. And it is bizarre when you turn it into images like that. And the more complex topics like closures and like inheritance and constructor functions and classes, it becomes really fun to use this means of explaining that concept, because you never forget it after it. You just simply never forget what a closure is after you've used some really strange imagery and story to break down what it is. My favorite is the this variable, which I actually represent as a turtle. And it stands for turtle hops in ship, like THIS, turtle hops in ship. And the ship is obviously the object, and it's that process of the turtle trying to find its way to the object that it's pointing at. But there's story and sort of concept story to show how the turtle finds its way to hopping into that ship. But again, a crazy way to think of the this variable, but I hated just even saying the word this variable, because you can't imagine it. But a turtle, I can imagine it. I will just hang around if there are any other questions or any other bits that we want to discuss. I mean, I would be very interested to hear if anyone has had a similar experience with learning JavaScript. Whether you are a beginner or not, it's irrelevant, because we all come across things that we feel we should know, but we just don't. And it can be disheartening, and you sort of start doubting yourself as a developer. And I think that's always going to happen. But JavaScript can be very nasty. That's why a lot of people just start tearing their hair out when you've been learning CSS and building these nice interfaces and started adding CSS animation, and you really are starting to feel like you are a creator. And then you get to JavaScript, which is meant to be this thing that adds like a whole beautiful layer on top of the web page that you're building. And now you are meant to be the master of your web page, but you can't get your mind around loops or, but yeah, that definitely happened to me. I think I said at the beginning that I had to keep looking something up, which still happens. I still do need to keep looking things up. But when it comes to concepts, that I can't really, that I didn't want to be looking up. I didn't want to have to read up again and again about scope and why something can't be found in scope and what is outer scope. That I don't want to be dealing with that kind of Googling in my job, or just as my day-to-day life as a developer. I wanted a pretty firm way of visualizing scope. And I guess also at the end of the day, what I was trying to what we're all trying to do is get to a point with our understanding of JavaScript that, yes, we know we're not masters of it. We're not going to, write our own React framework, but that we feel like we understand enough of the language that it doesn't scare us as much. Documentation being the biggest one. It helps with these visuals to go to documentation for something that you've never read before and you don't quite understand and is very scary. And it just is very scary, no matter how experienced you are. Sometimes, like, you read it and you're like, oh, where do I even begin? But the knowledge that everything is just JavaScript, and when you've been able to imagine all the different concepts that make up JavaScript and what drives JavaScript, no matter what framework or library or whatever it's been built, it all comes down to those same concepts. Like, it's just JavaScript, and you've just got to figure out their way of using JavaScript. But their way of using JavaScript is just using those same theories, those same concepts in unique ways, and maybe clever ways, like React. It just does very clever things with JavaScript. But after you've spent a lot of time with closures, you can see now what they were doing with React hooks. If anyone on this course is doing React, you're like, a hook is just a function, and everything I define inside of that function is only accessible inside of that environment, and it's a closure. And that's maybe different to the class-based React that you may have written or seen before, which there it's not using, we don't need to worry about closures as much, but we really do need to worry about this variable. And why do we need to, I don't know if you remember this, but you have to keep binding your methods and functions, and checking that this is pointing to the right thing. And it's like, oh yeah, it's just, it's the turtle. I just got to remember where the turtle is. Cool. I think that's the end of the session. So I'm going to call it there. But yeah, please email me or visit my website. Or I do have Instagram and Twitter, but I don't have it up. Kylo Robs or Dev Kylo on Instagram. And yeah, I hope you found it useful, and good luck with your journey as a developer. Thanks.